Actually, I went through it, and it seems I just try to understand everything in the slide. So I think I don't have any question now.
All right, perfect. In that case, we'll move ahead with the new topic. So like I told you yesterday, today we'll be starting with Java, basic Java. We'll see the syntax of a small Java program, what are the different components of a Java application, and we'll take it forward from there. Okay.
Okay.
So I'll just share my screen. Just give me a second. Let me know if you can see my screen.
Yeah, I get now.
All right, perfect. So today we are going to look into basic aspects of Java programming language. We'll see, yesterday we already saw how a Java program looks like, but then there are various other aspects of it which we'll be looking into them. What are different keywords that are used, how a class is written, how a method is declared, what are different components of a method, what are different type of variables that you can declare, how a variable is declared, and so on. So those basics which will help us to go forward and write our full-fledged Java programs, or rather application based on Java. So Java is also called as write once run anywhere programming language, and why that is called, we'll be seeing that in our later slides. So Java is a platform independent programming language. Now, any guess why Java is a platform independent programming language?
I think it is a cross-platform. It's work on Windows, Mac, Linux, and any operating system.
That's true. So it is independent of the platform, obviously. So that is why it is a platform independent programming language, which means if you run a Java program on a Windows machine, you can take that program and run it on a Linux machine or a Mac or any other architecture or any other hardware. You can run it on mobile, you can run it on microprocessor, anywhere you can run it, right? So unlike earlier programming languages such as C or C++, those programs had to be compiled on the device where you want to run it. Okay, so the programs could be written on any other platform, but if you wanted to run it, you have to compile it on that particular machine and then run it. Whereas in case of Java, you can compile the program on any machine and you can simply take it and run it on any other hardware. So it gives you flexibility as a developer that you don't need to compile and create the exe files, etc. on all the different machines where you want to run. And it is similar to C++ in syntax. So since C++ is also a object-oriented programming language, so the concepts that we discussed yesterday, the OOPS concepts, so they apply both to C++ and Java. So most of the things are almost similar, and that is the case with any other programming language which is based on object-oriented concepts, whether it is C# or any other that programming language that are based on the OOPS concept.
Okay,
it is similar to Smalltalk in mental paradigm. So in terms of flow, how the program executes, so there is another programming language called Smalltalk. So in that aspect, it is similar to Smalltalk. Pros are it is ubiquitous to net, so it is very versatile. You can develop applications for internet or web applications. The cons are interpreted and still under development. So it is still under development. Every time you see the new versions of Java comes up. So I don't think that as a con, because obviously new features, new enhancements keep on coming for any software that is there in the market. So
I agree.
That's perfectly fine. Now these are some of the interesting features of Java, which is automatic type checking. Right. So Java prior to Java, the programming languages that were there, whenever you, declare the type and you declare variables, so when you are writing the code, that time it won't check for the type and other uh, parameters. So only when you executed the program, then it actually told you that, hey, there is an error and so and so. But in case of Java, the compiler is very smart and it will do automatic type checking, it will do automatic garbage collection. What we mean by garbage collection is we'll be creating certain variables, we'll be creating objects, right? Now all these variables and objects, they actually occupy some memory, isn't it?
Right.
So any variable that you are storing, it is being stored somewhere. Now it is getting stored in your memory, which is nothing but the RAM. Every computer will have RAM, right? So all the variables that you are declaring, they are going and getting saved in the RAM. Now every machine will have limited RAM, isn't it? 2 GB or 4 GB or 8 GB, whatever is the RAM size. Now if you keep on creating objects, creating variables, and you don't free those memory, what is going to happen after a certain time?
It will be stuck.
So it will get full, right? The entire RAM, the memory will get full, and you won't be able to do any other operation. Your application will crash. Your machine will in fact crash, right? So you need to have garbage collection, which means that the objects which are no more being used, it has to be removed from the memory, and the memory has to be freed so that other applications or new objects that you need to create, they might use those freed memory. So in earlier programming language, you had to take care of all this, but in Java, it does this on its own. So you don't have to worry. It identifies on its own that, hey, this variable is no more going to be used. Remove the memory, clear the memory, right? So type checking, garbage collection, simplifies pointers. So no directly accessible pointer to memory. So in C, C++, there was something called as concept of pointers. The pointers are nothing but special kind of variables, right? Now what is special about them is that they don't store any value inside it. So in case of a variable, variables are created to store certain values. For example, if you create a class called person, inside that you will create variables such as name, age, etc., etc. Now these variables will be storing the age of the person, the name of the person. So they are what? They are values, right? So for example, the person has a name called Nabil. So Nabil is the value that you are storing in the variable called name.
Right.
Right? So they are storing some values. But in case of pointers, they are also variables, but they don't store values. Instead of that, they store memory addresses, right? So say you have created a variable called name, right? So that variable name will be stored at some memory location in your RAM, isn't it?
Right. Right.
Now a pointer will actually store that memory location of the RAM inside it. Instead of the value, it will store the memory address.
I get it. So we can move this pointer and to that address and return it back to a particular address and jump it to another address, right?
Right. Yes. Yes. So using pointers, you can actually play with very low level hardware, right? So pointers is actually giving you access to the RAM, right? The memory address of the RAM. Actually, you can play around with that. So, but as a normal developer or a normal programmer, the concept of pointers are very complex, because if you try to mess with memory, if you do something wrong, you are gone. Your entire application, not only application, your entire computer is running on RAM, isn't it? So
Yes.
if you screw something with that, your entire computer will go down. It will crash. Not only the application, the entire computer will crash. So Java said that why give access to such thing to a developer where it will raise a risk of destroying the application or the machine itself. So it has removed the concept of pointers altogether, and you have no more pointers inside Java. Okay.
Oh.
Simplified network access. So it provides a lot of libraries through which you can interact with different devices or different machines that are there on the network. Multi-threading, so it supports multi-threading, which means at the same time your Java program can perform 10 operations. For example, say you want to create 10 files, okay? So in earlier programming languages, if you wanted to create 10 files, you will have to create it one by one. So first file will be created, then second file will be created, then third, and so on. So it's actually taking more time, isn't it? Now,
Yes.
using Java programming language, you can at the same time spawn 10 threads, and all 10 threads will be creating the files at the same time. So you might have heard about multi-threading threaded processors. Yeah?
Mm-hmm.
So the concept of multi-threaded processors came from here. Right? So earlier everything used to happen using a single thread. A single thread is nothing but a single process. So using one process, only all your things should happen. Now if there is only one process doing the things, so if you want to create 10 files, obviously unless the first file is created, you cannot create the second file. Right?
Yes.
But using the concept of multi-threading, you can start 10 processes at the same time, and all 10 processes will be creating 10 files individually.
Yes.
So
Right.
you see, the amount of time taken will be reduced by 10 times.
Mm-hmm.
So that's another benefit of Java. So
Just going back to pointer. So in Java we cannot use pointer to make like jump operation like we do in C++ and moving the pointer from stack to heap and vice
no,
versa. We cannot do
no,
that,
you
right?
cannot.
Okay.
No, you cannot do that.
Okay. Okay.
All right. Now this diagram talks about how a Java program works. All right. So this talks about how the flow of a Java program happens, right? And it starts from here, from this part, the Java source code. So Java programs that we write, they are, we write it in a file. So you can open your notepad or your any text editor that you have, and you can simply start writing your code inside that. So any notepad you can start writing. It doesn't need a special file or a special editor. Your notepad is also good enough to write Java code. And the only requirement is that you need to save that Java file with an extension called .java. Okay? So normally the text file will be saved with an extension called .txt. Isn't it?
Can you say that again, please?
So if you create a text file, what is the extension of the text file?
Yeah, TXT, right?
TXT, right? For a Word document it is .doc or docx. For Excel file it is XLS. Similarly, for a Java program, it is
The Java.
.java, right?
Yeah.
So first you need to write your program in any notepad you can write and save it as .java extension. Okay? So that's the first step. Once your program is created and you have saved it as .java, so I'll just show you how we can save it as .java file. So say you have opened your notepad, right? And I can simply write my Java program as class person, and then I can write here string name, int age, etc., whatever, right? So I've written my Java program here, and then I can simply do file, save as, and here under double quotes, if I write say person dot Java, and then I save it on my desktop, right? So if I do controller, so you can see here, where is the person?
P. That P. Just.
Yeah, I'm pressing P. It's not finding. Did I save it somewhere else or what?
I'm not sure. You might.
I think it got saved into documents, I guess.
Mm-hmm.
No?
You may save it again.
Yeah, let's see. Save as desktop. Okay, we'll save it again.
Mm-hmm. Maybe you don't need the quotation mark, maybe.
No, so if you put into double quotes, then it will take the extension at .java. Otherwise, if you don't put in double quotes, it will take person.java.txt.
Yeah, oh yeah, right.
So it says it has a file called person.
Mm-hmm.
Let's see. We'll go to desktop and then where is the person? That's weird.
You can just
Here.
got it.
Yes,
got it.
see?
Mm-hmm.
Person.java, right? So if you
Right.
see, its extension is .java and it says it's a Java file.
Mm-hmm.
Alright,
Yeah.
so that's how you create a Java program. So once you have created your Java program, let's go back to our slide. So once your Java program is created, it needs to be compiled. So Java provides a compiler, because this is a high level program, right? You wrote something which is like English language code. So your machines do not understand English. They understand binary, zeros and ones, isn't it? So this program has to be converted into zeros and ones so that your machine can understand it, right? So to do that, Java provides something called as Java compiler. So when you install Java development kit, the Java JDK, so JDK will also install the Java compiler in your computer, alright? So you need to compile your program using the Java compiler, and you can do that by using, you go to CMD, the command prompt of Windows, okay? And to check whether Java is installed in your computer or not, you can simply type Java minus version, right? So it says I have Java installed version 1.7. Can you see it?
Yes.
Alright, so that's how you can confirm that Java is installed or not. And after that, if you want to compile this program, all you need to do is, first I need to go to the desktop, right? So cd desktop, and then I'll write Java C and the name of the file that I want to compile, right? And I think it should be Java minus C. Okay, so I think I need to go to, it's not recognizing, I don't have the class path set, so it's not recognizing the Java this thing. Okay, so in that case what you need to do is, I need to go to cd program files, Java, so JRE7, oh I don't have JDK installed.
Oh yeah.
Right, so that's why it's not finding Java C. Okay, so first requirement is that, so you can compile your Java program by writing Java C. Alright, Java C says compiled, so Java C means compiled. And if you write just Java and the file name, then it will run the program. Okay, so it's not compiling, you need to have JDK installed, so probably you install JDK and then you can run that command. So anyways, so when you run that command, it will compile your Java code and convert it into a .class file. So it will create another file called person, but with extension .class. Alright, and that class file is called as Java bytecode.
Yes, we can run the Java file directly from the one of the IDL, right? Like
Yes.
Blue.j Eclipse, and it will compile automatically.
Yes. So using Eclipse also you can do that, and that actually does all these steps that I'm telling you. It does all of them for you automatically behind the scene. So Eclipse also does the same thing. So it will be compiling your Java code and converting the Java file into class file, and then also executing it on the server, right? But you know, if you don't have Eclipse, so you should know the basics, right?
Yes.
So that's how you can do it. So once you have the class file, you can execute the class file by giving the command Java space the class file name, which is person.class. Alright. Now when you say Java space person.class, then what happens? So this second part of the diagram, this actually talks about what happens, this part, right? So this part talks about what happens when you give the command Java space the class file name. So the moment you give that, what happens is that the bytecode is moved locally or through the network to your something called as JVM. Alright. So to execute a Java program, you need to have something called as Java Virtual Machine or JRE installed on your computer. So Java runtime environment is something which is mandatory for you to install in your computer to run a Java program. So there are JREs available for every device. So for a Mac machine there is a JRE, for your Windows machine there is a JRE, different JRE. For your Linux there is a different JRE, for your mobile there is different JRE, right? So if you have a JRE installed on your computer, you can run a class file, right? So this class file you can create on any, say I have a Windows machine and I have written my program and I have created the class file. Now I don't need to compile this. I can simply take this class file and I can run it on any machine which has a JRE installed on it. Alright. Now inside the JRE what happens is, these are the steps that happen. So JRE has a class loader and my bytecode verifier which will check which will first load the class file and verify whether the bytecode is proper or not. Right? If the bytecode is proper, then it will be passed on to something called as a Java interpreter, right? Which will basically read all the lines of the bytecode, right, and pass that to the runtime system. So runtime system is nothing but a virtual layer which Java creates on top of your operating system. Alright? So every operating system will have their own way of understanding things. For example, if I have a Windows of 32-bit, right? So there is a okay, let me ask this. What do you mean by 32-bit Windows and 64-bit Windows?
The architecture of operating system.
Exactly. Right? So how is that going to matter if I run a program?
It's going to look on the kernel level and the operating system and the top of the kernel level, I mean. Because yeah. Go ahead.
Yeah, but how does it matter whether it is 32-bit or 64-bit? I mean, it's just a program. Say I have written a program.
Yeah, but we have hardware inside this machines that needs to be like the processor and the main core here, the processor. If the processor is 32-bit exactly. Architecture or the 46-bit.
Exactly. So the operating system is actually related to your processor, and 64-bit and 32-bit depends on the processor that you have. So if you have a processor which is of 32-bit, so you cannot install a 64-bit Windows on top of it. Now why is that so? Because if you look into the way how the memory is managed, it's all about boils down to how memory is managed, right? Everything is related to memory. So for a 64-bit computer or a 64-bit processor will have a memory which can store a number which is of 64 bits. Right? 64 bits. The size of a number can be of 64 bits. But a 32-bit computer or a 32-bit processor can store a number of only 32 bits. So if the number is more than 32 bits, it has different way of storing that number. Okay? So that is why your operating system has to be of that bit only, so that it also manages how the variables or data should be processed or saved. Okay? Now this part is about operating system. Now how does runtime, the Java runtime system plays this role? So what Java runtime system will do is, so the bytecode that we have created here, this might be created on a 64-bit machine.
Yeah.
All right? And we are trying to run.
Can you please just describe the bytecode, because I didn't get that.
Okay. So your processors, the 32-bit or 64-bit processors, they basically define what is the size of, maximum size of data that it can store in one memory location. All right. So it's related to microprocessors and all those concepts. So let's not go deep into it, but just for high level you understand that it actually varies on what is the size of a data that can be stored on a particular memory location. Okay, so for a 64-bit computer or 64-bit processor, it can store a data of 64 bits on a single memory location. Okay. All right, a 32-bit can store only data of maximum size of 32 bits. Okay, so that is why your operating system has to be of similar bits so that it manages the storage of data in particular manner.
Okay.
Is that clear now?
Okay.
Okay, and this Java bytecode, this can be created on, say, a machine which was of 64-bit, right? Now, if say I am taking this bytecode and trying to run on a computer which is of 32-bit, what will happen?
It will, maybe it will not work probably.
Right? Yes. So this is what used to happen earlier in C or C++, that you have compiled your program inside 32-bit machine, and if you take it onto 64-bit machine, there were issues. And that is why you had to again compile your C program on a 32-bit machine and then able to run it on a 32-bit machine. But in Java, that is not required. Due to this runtime system, in Java that is not required. Why? Because due to this runtime system or the JVM, I told you that you need to install a J2ee for every machine, right? For a mobile there is a different JVM, for a Mac there is a different JVM, for a 32-bit machine there is a separate JVM, for a 64-bit machine there is a separate JVM, right?
Even for virtual machine there is another Java virtual machine, right?
Exactly. So when you give a bytecode, when you provide a bytecode, so this JVM checks whether this bytecode was compiled on a 64-bit machine or a 32-bit machine, right? And if it was, so it will know that whether it was compiled on a 64-bit or 32-bit machine. And this runtime system also knows that what is the underlying architecture of your computer. And automatically it will, internally itself, it will convert this bytecode from 64-bit to 32-bit and then pass it to the operating system for execution. So as a programmer, we are shielded from the task of compiling your program again and again based on what machine I want to run the program. So that is why it is called as compile once, run anywhere.
Yeah.
Got the concept?
Yeah, I got the concept. Just I was confused with that class and Java bytecode. There is a that class, and I thought that that class is the same class we created inside the program, but it is not, right?
No.
Yeah, this is something. This is something the class that the compiler create to run the program.
Yes.
Okay.
So actually the words class, it is used at a lot of places in different contexts. So sometimes people confuse. Remember yesterday when we were discussing, people think class as an object, but class is not an object. It's just a representation of an object, right?
Yeah.
And you actually create an object when you write the new followed by the class name. Similarly here, the bytecode has the extension .class. So you call it as a class file, but it's actually not a class file. It's actually the compiled class file, right, which is executed by your JVM.
Okay.
Right. So it's little, conceptual, but once you get this thing clear in your mind, then you won't. So I hope now your confusion is cleared.
Yeah, it's clear now.
Perfect. So let's go ahead. So, alright, so Java is independent only for one reason, only depends on the Java virtual machine that we already discussed. Code is compiled to bytecode, which is interpreted by the resident JVM. J2ee or just-in-time compiler attempts to increase the speed, right? So here we had a just-in-time compiler, right? So this compiler is present inside your JVM, which allows you to increase the performance of your Java applications, right? So now there are also security features which Java provides. So you don't have access of pointers, which reduces chances of virulence program from corrupting the host, right? So I told you that if you don't have access to pointers, you cannot write code which can screw up your environment or a host, right? So pointer denial, applets. So applets are a special kind of Java programs which run inside a browser. All right. So in initial days of Java programs, Java 1 in 90s when Java was released, we used to create something called as applets, and applets were programs which got executed directly inside your browser. So when you gave a URL, so when you opened that URL, your applet programs used to get downloaded from your server inside your browser, and it used to execute. Right? So applets are even more restrictive, so may not run local executables. So there were a lot of restrictions on applets, which is they cannot run local files. They could read or write the local file system or communicate with any server other than the originating server. Right?
Okay,
so they could not run local files, they could not read or write local file system, they could not communicate with any other server apart from the server which is hosting that applet. So due to these features, your Java program were more secure, right? Otherwise what will happen? Somebody will write an applet and you open that browser, the applet will run in your browser and it will go and delete all your local files.
Right.
If it had allowed the access to do that. So,
Yeah.
so in order to avoid such kind of people doing those kind of stuff, it doesn't allow those things inside the applets. So
Yeah.
these are certain security measures that Java provides.
Yeah, so the applets, please, just a question. The applets is just when you go like the Java Verify website and I get like Java running in my browser, this is the applets, right?
Yes, yes.
Okay.
So Java programs, so there are class files present on the server and there will be a URL given to access those class files. So the moment you write that URL in your browser, that applet will get downloaded and execute in your browser. So the Java program that might be written inside it, you will get the output on the screen for that.
Okay, okay, clear.
Alright, so anyway, we have already discussed that Java supports object-oriented design and in turn it supports polymorphism, inheritance, encapsulation and abstraction. Java programs contain nothing but definition and instantiation of classes. So that we'll see how Java programs are written. Everything is encapsulated in a class because Java is an object-oriented programming language and everything has to be represented as a object and hence it has to be inside a class, right?
Mm-hmm.
Advantages, anyway we have seen it a lot of times, so I'll just skip that. Now we move to the basic syntax of a Java program, right? So before we go into an actual Java program, let's discuss certain terms. So there is something called as primitive type and variables that we use, right? So yesterday, if you remember, or rather even today, if you see this, I have declared a class and inside that I have declared a variable, right? Mm-hmm. And this is the name of the variable, which is name, and this is the data type of the variable, okay? Now this is called as the data type, this is called as the name of the variable, okay? Now data type tells that what is the kind of value that I can store in this variable. So string means this variable can store a string kind of value, okay? Int means integer, that means this variable can store only integer. Alright, now the question comes, why do we need to define the type? I mean, anything we store, how does it matter, right? So it matters because I told you that everything has to be stored in the memory, right? So if you are running a Java program, it has to be stored in the memory. So what Java does is that based on this declaration, it will know how much memory it has to store. So there is a specified memory for a string kind of variable, there is a specified memory for an integer variable, there is a specified memory for a float variable, right? So based on how many variables you have declared in your program, Java will allocate that much memory for you so that your program runs correctly. And if it cannot allocate so much memory for you, it will throw an error.
Yes.
Alright. Now these data types that I was talking, there are many such data types, right? And we call them as primitive types. So if you see here, boolean, char, byte, short, int, long, float, double, these are different kind of primitive data types that are present in Java. So these basic or primitive data types are the only types that are not objects due to performance issues. So these are the only data types that are not objects. Okay. Apart from the primitive data types, Java also has other data types as well, which we'll see later in the later slides. But for now, you can just understand that you have something called as primitive data types, which are which are not objects, and they are not objects just to increase the performance. Okay, so let me just explain you what is Boolean data type. So say if you want to store values such as true and false, or right, so whether it is true or false, so these kind of values that you want to store, then you declare a variable called Boolean. Alright, so you will declare it as Boolean, say ABC, right? And you can assign a value to this variable by writing as false. Okay. So a Boolean variable can only take two type of values, either false or true.
Right.
Right. Char is a character data type. So strings are, so string data type is a data type which can store a string. For example, Nabil. Right. So this is a string, right? Whereas n is a character.
Yeah.
So if you want to store just a single character, then you will declare a data type of type char. But if you want to store a string, then you will declare a data type of type string. Alright?
Okay.
Similarly, byte is what? A single character, 0 or 1 is a byte. So if you want to store a single byte, single number, so you will declare it as type byte. Short is if you want to store small numbers, right? Say numbers which are
12.
of the length, I think there is certain length of.
Yeah, 127 minus 128 to 127.
Yes, correct. Minus 128 to 127. Correct.
Yeah.
That's correct. So numbers of within this range can be stored under short data type. So if you know that in your program you are not going to store a number which is going to be greater than this range, so you declare the variable of type short, because based on that, I told you Java is going to store or allocate memory. So if you declare the variable as type int, it's not that it cannot store a smaller number, it can store, but rest of the memory is going to get wasted, isn't it?
Yes.
So it is suggested that you use proper data type for storing your variables rather than simply creating any variable and storing the value for your memory optimization. Float is again for storing your decimal numbers, double for storing large decimal numbers. Okay. This means that so next is, this means that you don't use the new operator to create primitive data types. That's fine. Declaring primitive data types. So this we already discussed. You can declare your variables and assign values in this manner. Let's go to next. So initialization. So initially, your variables, when you declare it in this manner, there is no value assigned to it. Okay?
Right.
The moment you assign a value to your variable, it is called as initialization. Okay? So assigning value to your variable is called as initialization. Initialization means what? Give the initial value. Right? So initialization means giving initial value to your variable. And this is known as declaration of a variable. Right? So this is called as declaration, this is called as initialization. It's just a term, so nothing fancy about it. So if no value is assigned prior to use, then the compiler will give an error. Java sets primitive variables to 0 or false in case of a Boolean variable. All object references are initially set to null. An array of anything is an object set to null on declaration, elements to 0, false or null on declaration. So by default, when you declare a variable, Java will assign either 0 or false for a Boolean kind of variable, right? For integers also it assigns 0. For objects it will assign null, right?
Okay.
So if you just declare a variable, Java will assign a default value to it based on what kind of variable it is. So if it is a string, it will assign null. If it is integer, it will assign 0. If it is Boolean, it will assign false. Okay? Or you can assign your value, right? So this is called as initialization. Alright?
So
and we already
do you think the best practice is to initialize the value in the variable in the first place?
How you can initialize the value here also, equal to, so you can do the declaration and initialization both at the same time. Right? So if you know what is the value that you want to save, you can simply write it like this. So it will do the initialization and declaration both at the same time.
Okay.
So Boolean ABC equals
False.
That's perfectly fine. Yeah?
Okay.
So there is again declaration which we already discussed. So I'll just move ahead. Assignment is nothing but assigning values to another variable. The same thing, right? Int a equal to 1. So I am assigning a value 1 to the variable a. Right?
Yes.
b equal to 2. So I'm assigning a value to variable b. So initialization, declaration, and assignment are all interrelated.
But how we can know that this b is double or integer or float? Or
Sorry, come again.
how we can know? Oh, we said integer in the beginning, so all of these are integer, right?
Yeah. So
Okay.
you can, yeah. So you told in beginning. So either you write it this way. So if you have multiple variables to create of same type, so instead of
Okay.
writing int a, int b, then you can
Okay.
write in one statement only,
Right.
comma b.
Right.
That's fine,
Mm-hmm.
right?
Mm-hmm.
So that's about it. So we'll just go next. So next we come to operators, right? So in Java we have various kind of operators. What Java, you have it in all the programming languages. So we have mathematical operators, which are nothing but plus, minus, subtract, and so on, right? And these operators work on the mathematical formula of BODMAS. So do you know about BODMAS?
No.
In mathematics, you might have heard of this term called BODMAS. In BODMAS, B stands for
Okay, I got it now.
bracket,
Right.
O for off, D for divide. You got it, right?
Yeah. So
M for
starting from brackets, division, then multiplication, then
yes,
start
yes,
other
yes.
operator. Okay.
Yes, perfect, perfect. So if you are writing number of mathematical operators, then based on the BODMAS rule, you know, it will be evaluated in that preface, which means first multiplication and division will. So BODMAS we have B or D. So division will be done first, then multiplication, then addition, then subtraction. Alright, so for example, say you have a mathematical operator something like 2 plus 3 minus 6 divided by 6 into 1, say. So the value of this will be, first it will do 6 divided by 6, which is
1.
1.
Yeah.
So 1 into 1, then it will be
1.
multiplied, so 1 into 1, 1, then it will do addition, right?
Yeah.
So 2 plus 3 is 4, right? And then 4 minus, here it was 1, so 4 minus 1, 3. So the result of this will be 3.
5 minus 1, 4, you mean?
Alright?
Yeah, okay.
So that's how mathematical operators work. So we'll just move next. So apart from mathematical operators, there are other operators as well. For example, comparison operators, right? So if you want to compare two variables, right? For example, you have a variable A and you have a variable B, and you want to compare and see whether these two variables are same or not. So in Java, we use double equal to compare two variables. So we'll check like A double equals to B. That means we want to check whether the value of A and B are same or not. Alright. Single equal to is the assignment operator, which means the value of B will be assigned to A. Okay. Similarly, you have other comparison operators like A greater than B, A less than B, and so on. Right? A less than equal to B. Right? So these are comparison operators that we use in Java. Then you have something called as ternary operators. Now ternary operators are operators which will take 3 parameters. So till now we have seen operators which take 2 parameters, right? So ternary operator takes 3 parameters. So I'll tell you how that works. So say you have a variable, you want to do a check. For example, say you want to check if A int A equals to 10. Suppose I have a variable called A, its value is 10. I want to check if the value of A is 10, then I want to say, I want to print the value is 10, else I will print the value is not 10. Alright. So normally if you want to do that, you'll write something like this: if A is equal to 10, right? Then I'll say A is 10, else A is not 10, right?
Right.
This is what I'll do. So in your C# or this, you might be writing if else statements.
Yeah.
Right? So Java also we write it in similar manner. So if A is equal to 10, say A is 10, else say A is not 10. Now this entire thing can be written in just one line using ternary operator. It's written something like this: a double equals to 10 question mark right. So the first part you write a equals to 10, that means, and then you write question mark. So what it does is that it checks whether a is equal to 10 or not. If it is a equal to 10, then it will do this, else, so this colon represent else, it will do this. So this is what is ternary operator.
So the colon means like this is the else statement.
Else,
okay.
yes.
Okay.
And this question mark is the if. So it
Yes,
checks
okay.
whether a is equal to 10 or not. If yes, then do this, else do this.
Okay.
Right? So instead of writing this big, you can write just one line. So those are different kind of operators that we have, right? So just move ahead. So a statement and blocks. So in Java, these lines that we were writing, right? So say we wrote the line called int a equals to 10 followed by semicolon, right? So any line ending with a semicolon is called as a statement in Java. Okay. So a line or a line in Java doesn't end till you don't give semicolon. You know, if I don't give semicolon here and if I write int a, int b equals to 20, these both lines will be taken as a single line. In fact, it will still not be ending. It will still be waiting for next line because I have not given a semicolon. Right? So that is why if you want to end your sentence, then you have to give a semicolon at the end in Java. Alright? So and any line ending with semicolon is called as a statement. Alright? So that statement, and in Java you use curly braces to group set of statements, right? So say I have this set of statements here and I write this something like this. So it is called as a block of code, right? So anywhere you can use blocks. So you want to group your code into different groups, you can simply put curly braces. So curly braces has no programmatical, meaning. It just says that these two lines are part of this block. Now this block helps you when you write things like, class. For example, you write class person. So it says that everything that is going to come inside this curly brace is part of this class. So it's like a logical, understanding, for logical understanding purpose, that all the code written between these are part of the person. Otherwise, you won't know that where your person class is ending.
Yes, but if we don't write this practice, we will not. We will have an error, right?
Yes.
Okay.
So for a class, it is mandatory to write these braces, but you also write braces for if statement, right? If else.
Yeah.
So you also write braces for if else. Now, in case of if else, it is not mandatory for you to write the braces. You can write if else like this. If say a double equals to 10, a is 10, else is not 10. So this is fine. In case of if else, it is not mandatory for you to write those braces, right? But say if I want to execute two statements inside the if. So if a is 10, I want to do two operations. One, I want to print this, and then I want to do something else. Then Java want to know that whether those two lines are part of if or not, right? So that is wherever you want to, group the set of statements for a single unit, you need to give the braces. Right? So blocks are for those purposes. So this data inside your curly braces are called as block of code. Okay. Now let's move to the next. So flow control. So in Java we have various flow control statements as well. So if else we already saw, right? That if you have a condition and you want to check, right? So if we'll put it here, right? So if you want to check whether some condition is true, then do something else. That's one kind of flow control. using if-else statement. Else is not mandatory, you can simply have if also. So if there is nothing to be done, if the statement is not correct, then you can simply have if statement as well. So if else, and then you have something called as switch as well. So switch is also similar to if else. Just any idea? Do you know about what is switch?
Switch like change, like switch this is not, it comes with if, right?
So switch is like your if else statement. For example, say I want to say if a is equals to 10, then
Switch
do something. Do something.
Okay.
Else if a is equals to 20, then do something. Else if
Oh.
a is equal to 30, do something. So you have like multiple statements like this, right? So if a is 10, then do this. Oops. If a is 20, then do this. If a is 30, then do this. So you have to write so many if-else statement. Now the same thing can be written using a switch statement like this. So you write switch, and then you want to switch based on the value of a. Okay? So whatever is the value of a, based on that you want to switch. You want to switch from one condition to another condition. So you write this, and then you will give the value braces, and then you say case 10, right? And you'll write your statement here. Then you write case 20. Your statements here. Case 30. Your statements here, and you can give default also. If none of them are true, then do this.
And no needs for if statement at the beginning.
Sorry?
We don't need the if statement before switch, right?
Yes.
Is that necessarily, but we can put it.
Yeah, this is not necessary. The default is not mandatory.
I
but
mean,
if
not the default. I mean, we don't need if statement before switch.
yeah. So it's interchange. Either you can use if statement or you can use switch.
Yeah.
Both does the same job. So based on,
we cannot use them together. I mean,
I'm not getting your question.
I mean, we cannot use, for example, the second portion with switch. So we can say if a equals 2, then switch a case 10. Like
No.
We cannot do that.
You cannot mix.
Okay.
Cannot mix.
That's my point.
Right?
Okay.
You cannot mix. So they are either you use this or you use this.
Okay.
Right?
Yeah,
and in your conditions you can use anyway. So you have this kind of scenarios. Then you can either write the same code using if-else, or you can write that using switch. Now the benefit of using switch is that, say the value of a is 30. Okay? So if say the value of a is 30, so what will happen in this case? First it will come here, it will check, hey, whether value of a is 10, no. Then it will come here, it will check, hey, the value of a is 20, no. It will come here to check, hey, the value of a is 30, yes. Then it will go and do this, right? So it is actually doing 3 checks, isn't it? The 10, 20 and 33 checks.
Yes.
But in case of switch, it will say the value of, in case of switch, it will see what is the value of a. Oh, value of a is 30, it will directly go to this case. Got the point?
Got it.
So switch statement gives little bit of performance benefit for you. So instead of doing multiple checks, in this case it is directly going to this statement. It's not going to check this and this.
Yes.
So you get a performance benefit, right? So again, it's up to you to decide, when you want to use switch or when you want to use if-else. So both the options are there, but you can decide in your scenario whether you want to look for more performance benefit. You can use switch or you can just stick to if-else. All right. Now there is one important thing about switch. So I told you that you need to you can write your statements here or here or here based on whatever case it is. Now say the value of a is 10. Okay. So what will happen? It will go to this case and it will write all the statements that are written inside this. Isn't it?
Yes.
Now what will happen is that after this it will also go and execute case 20, case 30 and default. Whatever code is below this, it will also execute that. That's how switch statement works. But we do not want that. We want that if the value of A is 10, it should only execute this block and then come out of it. It should not go and execute this.
Okay,
so to skip that, yeah.
We can use end, right?
No, in Java we don't have end. We have something called as break.
Break, okay.
Right? So break means break out of this switch statement. So at the end of every case, it is mandatory that you use the break statement. If you don't use the break statement, then what will happen? Say if the value of A was 30, then it will directly come to this case, and after this case, whatever other cases are there, it will go and execute that also. So in case of 30, it will execute this and it will also execute the default.
Okay.
In case of 20, it will execute 20 block, 30 block and default block. In case the value of A is 10, it will execute 10, 20, 30 default, all of them it will execute. So it is mandatory that without fail you give the last statement as break in each of your cases. In case of default, you don't need to give because default is anyway last. After this you don't have any case. So nothing will run. So even if you don't give break, it is fine. So break is a statement which is used to come out of any loop. Alright. So for example, say here in this if a statement, okay, in if a statement it won't go inside the case. So that's fine. So switch is understood, right? So again you have looping statements such as for, while or do while, right? So I hope in your C# or in .NET you might have used this for or while or do while loops as well.
I do.
Do you remember them?
Yeah.
So what is for loop?
For example, we can say for I equal something, do this, and end the statement, for example, and we can use
right? So what it will do, I have given the initial value of I as 0 and I am checking whether the value of I is less than 10 or not, right? If it is less than 10, go and do whatever I have written over here, right? And after doing this, increase the value of I by 1. So plus plus is another operator in Java, right? It is called as shorthand addition operator. Sorry. Shorthand addition operator, right? So if in front of any variable or any number, if you write double plus, that means it is going to increase that value by 1. So instead of writing this as I plus plus, you could also have written as I equals I plus 1. So this is also correct. But you know there is a shorthand, right? There is. So it is equivalent to writing I equals I plus 1. There is one more shorthand that we write. So I equals I plus 1 or I plus plus or I plus equals 1. These are all same statement. Right? So we have used shorthand that if first initial value of I will be 0, right? So it will go and check whether I is less than 10 or not. So the value of I is right now 0. So 0 is less than 10. Yes. So it will go and run this for loop. Then it will go back here. It will increase the value of I by 1 and it will check again whether I is less than 10 or not. So now the value of I becomes 1. So 1 is less than 10. So it will go again and execute whatever I have written here. Again it will go back, increase the value of I by 1. So now it becomes 2. 2 is still less than 10. So it will keep on doing that till the value of I becomes equal to 10 or more than 10. More than 10 it won't be. It will be 10. So 10 is not less than 10. So it will come out.
Yeah. So right.
Okay. So that's how your for loop works. While is also similar to for, right? For example, the same for loop can be written using a while. I'll show you how. So I'll write int I equals to 0, right? Then I'll write while I is less than 10.
Do this.
And inside, somewhere inside my while loop, I'll be writing I plus plus.
Okay.
Okay. So initially my value of I is 0, it will check here whether 0 is less than 10, yes, it will do whatever I have written here, and at the end it will increase the value of I by 1. Now it will go back again here, check the value of I is less than 10, yes, again it will do all those things, and it will again increase the value of I by 1. So in case of while loop, actually you have to do this addition and all manually. In for loop, in the for statement itself, you have written all those. But here you see, the initialization you have to do separately, the addition you have to write a line of code, right? But it's both the same thing, for and while. So you can use any one of these based on how comfortable you are. Okay?
Yes.
Now do while is also the same thing, but with a small twist. Okay? So I'll tell you what the twist is. So I say int I equals to 0 and I write do while I is less than 10. Okay? And here somewhere I'll do I plus plus also. So what is happening here? Initially the value of I is 0, so it will go here in that the do block, it will do whatever code I have written, right? And it will increase the value of I by 1, and it will check whether the value of I is less than 10. So yes, the value of I is less than 10, so it will go back again, and whatever code I have written here, it will do that, and it will do increase the value of I by 1. Again it will come here and check whether the value of I is less than 10 or not, and it will keep on repeating till the value of I is less than 10.
So what's the difference? What's the difference between this one and the one before?
Now tell me what will happen. If my initial value of I is 10, then what will happen?
So if it's 10, it will increase it by 1. It's gonna be 11. Okay.
No, so before that, the value of I is 10, right? And I have written a check that if it is less than 10, only then do that. Right?
Yeah.
But even though the value is 10 and I have written this check, it will execute for one time. It is mandatory.
Yeah.
Even if the value is 11, it will execute one time.
But would not continue.
And after that, it won't continue. But one time it will definitely execute, no matter what.
Okay.
But in these cases, if the value of I is 10, will it execute anytime?
No.
Because in the very beginning you are checking that whether it is less than 10 or not. But in case of do while, first you do, then you check. That means if the value is even greater, it will first do and then it will check. So at least once it has already executed.
I understand that now.
Okay. So I mean, we rarely use do while, but then there are certain scenarios where you want to do certain stuff at least once. Okay. So in that case, we use do while loops.
All right.
Okay. Now coming to the break. So break we have already seen. If you want to get out of any loop, you will use the break statement. For example, say when the value of I becomes 5, I want to come out of this loop. Even though I have written that till the value of I is less than 10, I want to continue it. Due to some reasons, I want that if the value of I is 5, I want to come out of the loop. Right? So I can write something like this.
Break.
So what will happen? When the value of I is 5, it will come here. It will check, oh, value of I is 5. Yes. It will go inside the if. It will execute the break. The moment it finds a break, it will come out of this while loop. It will not continue again. So if due to some reasons you want to come out of the loop before the loop condition is finished, then you can use the break statement. Okay? Is that clear?
All right, great, clear.
Continue is exactly opposite to the break. So say here, due to some reason, here what we are doing here is that after this if, we are increasing the value of I, right? Due to some reason, we don't want the code after the if statement to be executed. There might be some other code, right? Some other code here, something. But I want that if the value of I is 5, I don't want these codes to execute. Right? Then I can write here. So what will happen? That when the value of I is 5, it will check value of I is 5. Yes. It will go inside this loop and it will read the statement continue. The moment it gets continued, it will not run these lines, it will directly go back to this statement.
Mm-hmm.
Okay?
Okay, but it's going to continue anyway if it's 5, I mean, even if we don't try to continue here, it's going to be continue, right?
It will continue,
Yeah.
but it will execute these statements also.
Okay.
But I want that when the value of I is 5, it should not run these statements.
Yeah, just continue with checking.
Yes. Just
Okay.
continue with the loop.
With the loop,
Right.
okay.
So there might be scenarios. So I mean, Java gives you those options to do. For example, here you might have written some code to, print. Say I want to print the value of I. Right. So what this statement will do is that whatever is the value of I, it will print. Right. So normally, if you don't write this, so what is the output that you are going to get? On the computer screen, you will get something like 1, 2, 3, 4, 5, 6, 8, 9, 10. Sorry, till 9 only you will get, right? This is what you will get if I write this program.
Yeah.
Isn't it?
Yeah.
Now my requirement is that I don't want to print 5. Right? Then what I'll do? I'll write if I equals to 5.
For 5, just continue.
Continue. So what will happen? If I is 5, it continues. So it won't go and print, it will simply return back here.
Okay.
So it won't print 5.
It's clear.
Understood?
Yeah.
So that's about break and continue. Return. So return is a statement which we use inside your functions to return some value from a function. For example, say I have a function called int add, or in the add method. Remember yesterday's add method? And I'm saying int c equals a plus b. So I have added these two numbers and I've got the result inside another variable called c. Right? Now what I want to do is I want to return this result back to some other program. There might be some other function who might have called this add. I want to return the result to that. So in that case, we will write something like return C. So what it will do, whatever the value that is there in C, it will return that from this function to another function. Okay. So whenever you want to return some result from a function, then you use the return statement. Okay. And whatever value you are returning, right, the data type of that should be written here in the function declare. So this was the signature, remember?
Yeah.
So the first variable is the access modifier. Okay, so public means this method is public. Second word is the return type. Okay, so I am going to return a value which is of type integer. So I need to write here int. The return type has to be int. If I am going to return some string, then the return type would be string. If I am going to return a decimal number, it will be decimal. So whatever is the type of value that I am going to return, the data type will be that type. Okay?
So even if we change the variable names inside the parameters and put it like
doesn't matter. It's dependent on data type.
Yeah, I mean data type in the tab.
So
like in the signature, we change integer to double for both of them. All right, and return integer. It will not return.
It has to be
double,
integer,
right?
yes.
Yeah, okay. But
it doesn't matter what is here. It matters on what you are returning.
Okay, great.
Okay. So it only looks at what is the data type of the value that you are returning, not on these parameters.
The signature. Okay.
Okay. Then the name of the method. So add is the name of the method, and inside the braces the values that you are giving to this function. All right. So that's what return statement is. Okay. So these are flow controls. So these actually talks about those that we already discussed. So I'll just skip this. Relational operators we already discussed. So Skip that too. If else we discussed, right? Skip that. Nested if, we saw nested if as well, right? Multiple if else we can write.
Yeah.
So just skip that. Else if, skip that. Because this just gives an example of a correct program and a wrong program, right? So just skip that too. Switch statement we discussed, right? So we'll skip that too. Loop we discussed. So you can also write nested for loops, right? So inside one for loop you can write another for loop as well. That is fine.
Right.
Right? It's like this. So this nested for loop. Skip that. While loop we already discussed. So go ahead, do while loops. Break we discussed. Continue we discussed. Then arrays. So array is another data type that we have. Right? So arrays are used to store multiple numbers in one variable, right? For example, if you write int a, so you can only store one value, right? But say you want to store multiple values in the same variable, then the Java provides something called as an array. So you declare an array something like this, right? And you can assign multiple values to the array like this. 10, 20, 30 and so on. So this single variable is having actually 3 values inside it, and you can get the values by writing something like this: a bracket 0. So it will give you the first value, right? If you write a bracket 1, then it will give you the second value, so on. So if you want to store multiple values of same type, right? So one way is that you create 3 variables: int a, int b, int c. Say you want to store 100 numbers, then are you going to create 100 variables? No, right?
Yeah.
It will be very difficult. Your one page of program will have only variable declaration, isn't it?
Right.
So instead of that, what we do, we declare an array like this, right? And we can assign all the values, 100 values or whatever values, to the same variable, and you can access those values by writing a0, a1, a2. If you want to access the 100th value, you write a99.
What if we want to access like 0 and 1 in one line, like a0, comma 1?
No.
We can
only one value you can access at a time, right?
At a time, okay. Okay. But I think there is a way we can get a list from the array, or we can't.
No. Arrays are single dimensional, so you can get only one value at a time.
Okay.
Okay. What you are talking is of multiple dimensional. So array is a single dimension, so you can only get one value at a time. Multiple dimensional arrays are there in C and C++. So there you can give comma and you can get values like that. But here it's not that case. Okay. So
do we have a list? Do we have a list? And
yes, we have a list. We'll see that in next session when we discuss about advanced concept of Java. Okay.
Okay.
We have arrays, so assigning values, fine, iterating through arrays, you can run a loop.
Can we go back to the declaring?
Yeah.
I just want to see the slide. Okay, just put it in new, right? We have to put my array equal new like this.
I mean, so this is also correct. This is also correct. This is also correct. There are a number of ways of doing the same thing. So whichever you want. So if you know that your array is going to be of size 8 only 8 size array, so you can create it like this and give the size.
Okay.
Yeah. So the different options are available. So whichever you want, you can use those. All right. So going next, so this assigning value. So you want to assign value 3 to the first location of the array. So you can do like that. So on, or you can assign all the values in one go like this, which I told you.
So if I created array with 100 dimensions, then I said my array 0 equals 3. The first one is going to be 3 in the array itself.
Yes.
And I have 3, 1, 2, 3. That's right?
Right.
Okay. Just make sure.
So if you have 100, you have created an array of size 100 and you assigned only 0, 1, 2, 3. So the first 3 values will have values 3, 6, 3 and other 97 values will be empty. Okay?
Okay.
So this iterating through arrays, so you can, to access the values you can also run a loop and access all the values, so you don't have to write array 1, array 2, array 3, because the 0, 1, 2, 3 are what? Numbers. So those numbers can come from your loop, the value of I, right? And you can write I instead of the value. So first time I value will be 0, so it will be my array 0. Then the value of I will become 1, so it will be my array 1. So that way you can access your values from the array by loop also.
Okay.
Array of objects. That's fine. Declaring arrays. Let me see. Java method and classes. So we already discussed, right? What are methods, classes? So these are again talking about the OOPS concept. So let's skip this. Method we already saw. What is a method? What is a method signature? Public, private we saw. Using objects we'll see. Constructor we'll discuss. Alright. So overloading we already saw. Java development kit we discussed. Alright. So now rest our advanced topic of Java. So tomorrow session we will be looking into the other advanced topics of Java, right? Where we'll write a small program and see how do we write a small program, access different aspects of Java. Okay?
Okay.
So meanwhile, I would suggest you install JDK and Eclipse in your computer.
I have a BlueJ, my computer.
Oh, you already have it?
I have, yeah, I installed BlueJ in my computer and I use it. Not Eclipse, BlueJ.
That's fine. That's fine. Then we'll use that only. Yeah.
Okay. Okay.
Okay. All right. Get then.
Okay.
So we'll continue tomorrow with the advanced concepts of Java. We'll discuss about lists as well tomorrow in the tomorrow session. Okay.
Yeah. All right. No problem.
All right then.
Okay.
Thanks then.
So
Bye.
I have just a question. I know you have maybe another batch coming soon, but I mean you're having more than one batch in the day, right?
Yes, that's true.
Okay. Yeah. So I'm not sure if you are available other time than this.
At what time?
I'm not sure when you will be available other time rather than this, because this time is not so comfortable for me.
How about from 10 p.m. IST, an hour later? Is that okay for you?
10 p.m.?
Yeah.
Yeah,
But
that's
10
so
p.m. for me. Not yours 10 p.m. but mine 10 p.m.
Yeah, that's so perfect.
Which will be like an hour later than what we start normally.
Wait a minute. 10 p.m. or a.m. you said?
So what is the time right now for you?
The time is 11:50 a.m.
11 a.m. right? So how about 11 a.m.? Is that okay?
I mean, sometime like 4 p.m. like afternoon class.
Actually, afternoon I'll be having my office.
Okay, you're in the office. Okay, you cannot do it like even.
Yeah, because that times I'll be having my office, so
I mean,
it's difficult.
even in evening time, you cannot do it, right?
Yeah, that's it. So I can either do it an hour or two before or after in your morning. So if that's fine, but in your evening it will be a little difficult because that time I'll be in office itself. So
okay, no problem. So we'll keep it right now for this, and they will let you.
Sure. All right. Perfect.
Thank you so much.
Yeah. Thanks so much.
I appreciate it.
Have a nice day. Yeah. Bye.
You too. Bye.